Okay, now we move over to page 3 of the handout and we start solving equations that contain decimals. On this equation, it's pretty much like the one with the fractions. What you need to do, you want to first clear the decimals so you're not working with any decimals, just like we weren't working with fractions on the examples on the first 2 pages. So what we're going to do here, we're going to multiply both sides of this equation by the power of 10. This 100 is a power of 10. The appropriate power of 10, which is going to eliminate all the decimals from the equation. So what we notice is that in this problem, there's there's 3 decimal numbers, and if you notice, the first decimal number has 1 digit to the right of the decimal, second one has 2 digits to the right, and the third one has 2 digits to the right. So I find the decimal number that has the most digits to the right. Well, this one has 2, this one has 2. So the one that has the most digits to the right is 2. That tells me how many zeros to include in my power of 10. So I'm going to multiply both sides by 100. Now, to do this is very simple. All we do is move the decimal point 2 places to the right since I'm multiplying by 100. That's where this 35 comes from. Now, I do the same thing over here on this one. When I move the decimal point 2 places to the right, notice that I get 335. Now, the point 2x is a little trickier. When I move the decimal point 2 places to the right, notice that there's a 0 that ends up being after the 2, so I get 20x for that one. So all we're doing here is distributing the 100, but doing it very easily by just moving the decimal 2 places to the right on all of the decimal numbers. Well, if you look at this equation right here, this equation has no decimals in it. Now we can apply our 4-step procedure: simplify, eliminate, isolate, and divide. So I need to do the simplifying step. So I'll take this 35 and I'll distribute it to eliminate these parentheses. 35 times x gives me 35x. 35 times 3 gives me 105. So next thing I do, I combine my like terms. I notice that the first and the second are the same. So I combine them and I get 55x. Sorry, 55x right here. Now there's only one term that contains a variable, so the elimination step is not necessary. So I'm going to isolate this by adding 105 to both sides to cancel out this 105. By doing that, I get 55x over on the left. On the right-hand side, 335 plus 105 gives me 440. Divide both sides by 55, and I get an answer of 8. So I should now take the 8, plug it back in to the original equation that's not written up here. Go to the original one that contains the decimals and show that the left-hand side and the right-hand side are equal. After you've done that, then you write your answer using set notation. Put the 8 in the parentheses. That's how the rest of these go. Notice they're already all worked out. The only thing that you have to be careful with, now look at this example number 3. Do you see this number? Where is it? Right here is not a decimal. But even though it's not a decimal, since I'm multiplying both sides by 100, that 6 also has to get multiplied by 100, which gives me 600 right here. Don't just simply move the decimals 2 places to the right. You have to make sure that you're multiplying the whole left-hand side by 100. So this number right here, must also, this 6 right here must also get multiplied by 100. So that's the only thing you have to watch out for when you're using this method of clearing the decimals from the equation. Make sure that you read the rest of the examples and do the few problems that follow.